ไม่ได้เปิดอะไรอีกที่ Since the morning, any question? Okay, we just recap why we need vibration, because we are doctor, right? We understood vibration is hard to know machine health. Like a doctor want to know our heart beating, our pulse, our lungs. Yes. Now we know about the signal processing a little bit. Okay. So we carry on after this in the morning. Again, I want to emphasize knowing much will kill you. More expensive because you afraid that we never know before, never heard before. But it's telling you the truth. You have to understand the language. When you understand the language, you can manage the list. Less equipment to make money, not repair it. Just repair it before it dies, not let it die. Because when die, we pay very expensive for log scale. Okay, now we know this. What is too late? Upside is too late. You don't change any bad judgment. Many pieces have to change. Yeah, you have to go to a little bit before bearing at the left button. But this one is okay. You maximize the machine before it fails. Stop first and then change the bearing. We know about this. Okay, the advantages. This line. Just go to proactive maintenance. We have to proactive. We have to know machine health upfront and manage it. This is precision maintenance. Okay. Now we work about collision based and precision. Forget about predictive maintenance. This is wrong. People call wrong meaning. Today we cannot go live predictive. Only prognosis. Predictive, that means like I am a healthy man. I go to see doctor, and doctor say, hey, you're going to die next year. That's predictive. If I go to doctor with my sickness, please check when you're going to die. Doctor said, hey, you're going to die next year. That's prognosis. That is the way. Today we just living with prognosis, not predictive. Okay, in future it can be predictive. I also develop a new program to be really predictive, but it takes time more than this. Okay. Now we know this. This is a pyramid of cost. But it doesn't mean the top one is the best. It depends on equipment classified by another way of study we call RCM, reliability center maintenance. Some machine no need to even to repair, let it fail, because maintenance costs may be higher than equipment costs. Depend on the consequence. Machine for making money, so depend on the consequence of machine making money. That is the way to make decision. So we have another tool to design maintenance. We will come to this in another training. Okay. We talk about the power plant. She crying. She was crying. I'm not good. I feel sick. Please help me. Please help me. But nobody listened. So one day, she wrecked in pieces. Now we know about Mobius. We know about recap. Okay. We know about signal. Displacement is the fundamental. Without displacement, nowhere to be velocity or acceleration. But in practical, we use acceleration to measure, and then we integrate back to velocity to get a better frequency response. I try to say displacement, velocity, and acceleration all the same, only measure different timing. Okay. So we can integrate. That is the way. Again, sensor is acceleration. Then we integrate to velocity. So we will have good, better bandwidth, good frequency response. Okay. We integrate. So it became flat. It's flat. Before, it's short like this. Because velocity. We use acceleration, integrate, then flat, and longer, more bandwidth. That's where a measurement. So this afternoon, okay. Let's try to this. Before lunch, I demonstrate you free vibration. You never see on your life. I make it for you special to understand what is the free vibration. It's vibrated by its own will. Its own will. That's what we call free vibration. But the source of free vibration, we have to force this. We call excitation. So sometimes machine vibrate fast and free all together. As always like this. So not only fast or only free, but mainly it's force vibration. So it's good for you. That spectrum help you. I said mostly it's fast, but it doesn't mean all fast. Like bearings. Bearing when it fail both fast and free. Okay. Vibration in this machine first to a foundation. So became force vibration. I check a machine. I check. Oh, don't you believe? Don't you believe, man? I check my product. I testing. I forces. This is V-Mer. So V-Mer is let me see. Can you hear me?
Yes, we can hear you.
Okay. Okay, let's be good. Huh? Okay. So next one is dam. Again, before lunch, I show you spring, I show you shock absorber. In your car, we have shock absorber. That's we call damping. In your car, you have strut, we have spring, that's spring. and you sit in the car, that mass, your mass in the car. So when you feel car is bumping or vibrate because of the combination of mass, stiffness, and damping. Next one is spring, damping. At the bottom is exciting, the source of vibration. The red one, the upper one is the, sorry? The second one, I mean the top one, it's the result. Again, bottom is the exciting. Top one is the result. You see happen. It's past spring, we have damping, like a spring I show you in before lunch. Okay, this you see the mass shake when you take a video. Okay, now is animation. Bottom is exciting. The up one is the result. We pass mass, stiffness, and damping. You see now it runs faster, but upside is vibration higher. We run faster and faster. Run faster, faster. Then it's vibrate less. This is the way of vibration. When you measure the upper part. But actually happen inside your machine is lower parts of this. So don't assume when you measure it's good or bad. It's very complicated. I try to say high vibration, it doesn't mean bad. Low vibration, it doesn't mean good. It's complicated than that. Because we talk about the mass being damping stiffness. And damping, sorry. I run slower, I excite slower. The upside also respond the same. I run faster, faster, faster at the same magnitude. Now upper is higher magnitude. What the hell is this? Run faster, faster, faster. The magnitude upside is reduced again. Faster, faster. Then it kills each other. Became less vibration. That's why don't jump in conclusion. High vibration is bad. Low vibration is good. No, and I tell you, under this circumstance, low vibration is very dangerous because you think it's good vibration. That's why you have to understand free vibration, forced vibration, damped or undamped. Now we talk about damped and undamped. Now you show the damped, right? Now we go to random. Random is signal that cannot convert to spectrum. You see exciting. Signal is random, not pure sine wave, and not constant period. So when you convert to spectrum, it's gone. You don't know. That's why we cannot use spectrum in shock. In reality, we have the different subject, shock only. We don't talk about spectrum anymore. We call spectrum density. We use spectrum density for shock application, not spectrum. Now, it's a little one. I shake my bell. Where's my bell? I shake my bell. I shake only one. The rest is echo, like echo. So I force and then it's free. I saw it. Again, at the bottom, it's exciting. The upper is less fun for my shock, and then it's free. Shock and free. You see? Shock and free. Shock and free. Excite and free. Excited and free. Excited and free. That is, it is about shock of excite and free vibration combination, and it's happened in the real world. Another shock and free. Oh, sorry. Stamping machine, bang, and then shock and then free. Shock and then free. Shock and then free. Okay. Now we come to nonlinear. Jason mentioned about looseness. Have a look in the screen. Now I erase this because you understood. Okay? FFT, sign, time domain, blah. Spectrum help you 80% problem. Spectrum for human. Automatic, no need. Because it's not human. It's not clever, but it's faster. Never tired. Okay. 30% spectrum cannot solve. So we have to go down to time. We call time domain or time waveform. It's the same thing. Okay. We talk about orbit. Today, you don't need orbit. Orbit is just for turbo machinery to see how is the sharp position inside the bearing. What happened? Okay. That orbit is based on displacement. Because I want to know where is my shaft? Where is my shaft? That is the way. Okay, I erase this. Wait, love it away. Huh? Love it. Thank you to Mr. COVID. That's what I have today.
It's nice assistant.
Yeah. Oh, what? Sorry. Alcohol sheet มีไหม มีขวดแอลกอฮอล์อยู่แถวนี้เป็นไรโอเคเชื่อให้ เปิดมือไม่ไหวตอนนี้นะ We talk about non-linear. You know random already. You see it's by animation, but non-linear is hard to animation. Piston. Go to the crankshaft, and then piston move back and forward. Crankshaft is move a circle. Yes, linear. Piston move top dead center, bottom dead center is non-linear. But the way of measurement, I put my sensor. I put my sensor here, or anywhere. A signal come to my sensor. It have both linear and non-linear. We have one piston. We have 3 piston, 6 piston, all the same phenomenon. After this training, don't try to interpret spectrum at piston engine. Piston compressor, piston engine is totally wrong. Somebody crazy interpret even cylinder number 1, cylinder number 2, cylinder 3, bullshit. Even 1 cylinder or 12 cylinder is give all the same phenomenon. Because we integrate a time, 6 times coming like this, and then coming from the piston. It's not linear. So when we measurement by digital or by real, a signal coming is not constant. So when you convert to spectrum, it became like this.
Katanya Beberapa kamu.
1, 2, 3, 4, X. This is not proper spectrum.
Kenapa? Aduh.
It's not proper spectrum. Spectrum cannot convert the signal. So when integrate from 0 speed to 0, 1, it's not constant.
Ini ada.
Somebody please mute the microphone. Okay, thank you. Let me recap again. This is non-linear. Don't try to use spectrum analyzer.
PS.
Do the D, please tell somebody mute microphone.
Yes, we have.
Okay. Now we talk about non-linear. Non-linear. This is linear. Motor running is linear. Turbine running is linear. But piston engine is non-linear. It changed from linear, cover linear, to rectangular linear. So velocity here is not constant. Hello? Piston here is not constant. So when you integrate a signal from a time derivative, this is a time. This is time. Tick, 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 tick. When you integrate, spectrum cannot mapping. Because mapping is a frequency domain. Let me explain about time. Domain. frequency domain. Time domain is based on time. This is time. Frequency is based on frequency. Different domain. You cannot change a man to the woman. Change woman to the man. Different domain. So when you calculate a signal from a time, but signal is not constant period. So spectrum cannot convert because spectrum based on assuming. First, sinusoidal. Second one, have constant period. That's the way when you use machine, vibration analyzer to detect a piston engine, it's come with like this. It's not about silent 1, 2, piston number 3. It's bullshit. It's totally wrong. Okay? I tell you, I believe half of you here is wrong. Not only you, entire world. Because people don't know exactly real vibration. Yeah, just follow the tool, but don't know how it's tool working. Even the salesman tells you to, don't know. So even one piston also keep like this. Because even 10 piston, 12 piston V engine, don't care. When it's changed from time domain to frequency domain, they don't know how to mapping. So it's coming like this. Okay, this is the way of non-linear vibration. So when you measure a machine with the variable speed, also be careful. So before you measurement, just change variable to constant first. Then help you a lot. That is not linear. This is a crankshaft. Convert collinear constant change to cosine from collinear to rectilinear, transmit to piston. You cannot use spectrum analyzer. Somebody use that means misunderstand. But people use spectrum for this machine. For the skill machine, they use differently. They set frequency response much higher. They set frequency response much higher. They don't care about this. Bullshit. But something wrong with your piston, crosshairs, bang, bang, bang. It tells you. Resonance. Or, another word, free vibration. You see it? They don't care force vibration. They care vibration. When something wrong, they don't care signal here because it's crap. They know spectrum cannot convert, so this is a crap. But they set very high frequency to see something wrong happen when machine break. That's a way to analyze nonlinear machine. However, in the last session today, we will come to this, how to measure this, but not spectrum. We have ISO standard 1018, 1016 dash
108 16.
New. You never heard, right? Because we know only. Here. We have number 4, number 5, number 6, 7, and today we have 8. So number 8 is for non-linear machine and very difficult to measure. Hello? 1716 is not difficult to measure. It's not easy to measure. Okay, it's complicated. I will come you the last section. Okay, next. That is the signal. You see signal here. It's not periodic. Sometimes high, sometimes low, something this. So when you convert to spectrum, you lost information. Okay. Next. Today we talk about lateral vibration. The meaning of lateral vibration. I have my pen. It's vibrate like this. It will vibrate like this. This is a lateral vibration. If it's vibrate like this, if it vibrate like this, it's vibrate like this. It's rotated and also shaking. We call torsional vibration. Forget it. Tool cannot measure. Must be special tool. Okay. Today we talk about lateral vibration. But in the real world, you may face a problem, torsional vibration, but you don't know. The point is, machine before to the market, they sold torsional vibration. Otherwise, they cannot sell. But by your own mistake, you modify. You add mass, you put VSD. VSD. People who sell VSD said, hey, I'm good. But they don't know machine impedance. Many VSD kill the machine because you change the frequency, you change the speed. Then speed come to a speed that designer want to avoid. So many cases you have sharp break, gear teeth broken, mechanism failure, sharp key gone. Mostly is from torsional vibration. And you cannot use equipment to measure it because they cannot measure. It's measured by special tool only. Okay. Any question for this? So we talk today about lateral vibration, but torsional vibration also the same phenomenon, but no tool. I mean the general tool to measure. We have special tool only. Okay. So this is torsional vibration. It's twisting. Vibration. Here, mx to dot plus cx1 dot plus kx equal force 0 sine omega t. I try to explain sine omega t, t is the time, we talk about time. Because it's loaded. We don't know loaded to where. It's just repeat. So in the real one, we have to stop that time to be steady state. Then we can learning vibration. That is the meaning. Omega, that means the angular speed. We don't talk about RPM. In engineering, don't know RPM. We know omega or any radian per second. In practice, we know hertz, RPM. Engineering, don't know hertz, don't know RPM. We have to change to radian per second. One circle equal to pi radian. One circle, 2 pi radian. Yes, okay. That means the force happen to the certain time, transmit to the way we touching to spring, shock absorber, and mass stiffness. Come to your car will fall to the small ditch, right? You bang, yeah. You transmit to your car body, to your spring, to your shock up, to your seat, and this is your body that sit on the seat. Then you feel vibration, shock. Oh, this is a vibration. That's the way. Go to the bottom one. Now we talk pump and motor. All the same. Okay? But car is not vibration, it's shock. Machine is vibration because they have constant period. That means simple words, constant speed, constant RPM. Okay, any RPM but constant. The source of vibration, maybe it's come from unbalance, misalignment. I said in geo offset, geometry offset. Maybe soft food, spice strain, or fluid induced. Fluid induced. I show you something. Okay. Oh, I'm sorry. I don't have it here.
As you can see, this bridge was exceptionally long and narrow, over half a mile long, only 39 feet wide. It lasted just 4 months.
No video, sir.
Just a moment, sir.
Okay.
Thank you. Just a moment. Yeah, thank you. This breath is failure from torsional vibration. But you can see by your naked eye because it's not round shape, it's a flat shape. It's a flat shape. That's why we can see it twist. And it's failure because fluid induced. In this case, only wind at 40 miles per hour is not strong.
As you can see, this bridge was exceptionally long and narrow, over half a mile long, only 39 feet wide. It lasted just 4 months.
Only 4 months from construction. From using, sorry. I go first. Okay.
Is observed during the entire. Here's opening day.
The way is opening day. Only 4 months. It's not resonant. Resonant is free vibration in torsional mode.
On November 7th, the bridge suddenly went into a twisting motion. The wind speed was a steady 42 miles per hour. This was enough to keep the bridge oscillating in one of its natural modes of vibration with a period of 5 seconds.
Breathe is vibrate. It by natural mode. That is a free vibration. At the frequency, he talked about 5 seconds. We will count on 5 seconds later. It's vibrate because fluid induced.
A professor of engineering went out to see what had happened. He's coming back, walking with some difficulty along the nodal line, which is the center stripe of the roadway. It's remarkable that the girders were this flexible.
It is strong, right?
This is photographed at normal
Strong
speed.
breath.
However, a collapse was inevitable after a little more than an hour of this.
It can be stand for 1 hour by twisting the wire. Now start to break. You see the wind from the trees. It's not strong, only 42 miles per hour.
The car had been abandoned earlier. No one was injured in the whole affair. However, a small dog in the car was frightened and was afraid to come out, and he perished along with the bridge.
So the dog dead. Now it's breaking. You see from the dust, it's not strong wind. That is a way of fluid induced. Combination with resonance or free vibration. Before lunch, I show you a small spring shaking light here. When at the light position at the spring. Remember? Okay, I stop this. So that is a fluid induced. Okay, that's a fluid induced. That is fluid induced. You see it. So exciting from vibration. Exciting to vibration. It comes from either unbalanced, geometry offset, or fluid induced. Only. Come to fluid induced. A blade cross section from the video we have seen is long blade. When the wind blows, it creates vortex. When we have vortex, it's lift, it's push. That's why it's vibrate in torsional mode. In torsional mode, like this. That's a bit collapse. I mentioned about this vortex. Because when the velocity coming here became turbulence here, it's vortex. Pressure here is different. Then it's push. Vortex collapse again, it's pull back. Push, pull, push, pull, pull, pull. At the same 5-second period. He said in the video, this vibrate in one circle 5 seconds. How many hertz? F equal 1/T. F equal 1/5. How much? 0.2 hertz. Very low frequency. Okay. In our machine, we never measure this velocity. So most of the structure vibration, we talk about 1 hertz, 2 hertz, 0.5 hertz, 3 hertz. Because our machine, we limit 10 hertz. Mostly. Okay, some machine has 1 hertz. We have like a big machine, hammer mill in the cement factory. It's very low speed. You cannot measure vibration. It's meaningless vibration for this. We measure something else. And any machine can do, but people don't know how to do. And believe people lies. Oh, I need this, but it's not. The point is people try to detect vector, but there's no vector there. Because 1 hertz, very slowly, is no dominant from unbalanced. No way. Even I have unbalanced 100 kilo, it doesn't give vibration. Okay, next. This page, now you understand. Okay, let me recap again. The source of vibration is inside your machine. It makes displacement. As it's forced to outside, to mass, spring stiffness, spring, damping, and your feeling. All this means your sensor is here. And we measure here at acceleration. X2 dot is acceleration. C1 dot is velocity. K1 dot, K no dot, this displacement. So this combination. So when you measure vibration, you measure at this point. When you put your hand to feel it at this point, you see by your own eye, also at this point. Yeah. So be careful. Inside, different. Different. Yeah. Come to the real world. This is a motor. Motor has bearing, rotor, and bearing also put in the housing and transmit to the body and to its footing. So it equivalent to this mass stiffness. Vibrations happen inside, even unbalance or misalignment. Misalignment happen outside, but it gave result to inside. Inside transmit to your bearing, to your spring housing, bearing housing, and then transmit to your body and to the ground. That is the way. We measure vibration here. We measure vibration here. But what happened inside? So be careful, don't assume. That's why I try to point high vibration doesn't mean good. Low vibration, high vibration doesn't mean bad. Doesn't mean bad. Low vibration, it doesn't mean good. Yeah. Now tell me, I will show you video. Can you tell me this video? Sorry, Zoom cannot transmit the high frequency. And if you observe at the right fan, it's vibrate. The right fan is the same fan, but without pixel magnify. Without pixel magnify. Sorry, we cannot see this. Okay, useless for this. I want to ask you about question in this picture. Palako is digital problem. Not me, Zoom. Stop. Okay, now I ask you, unbalanced force or free? Misalignment force or free? Bearing force or free? Electrical problem force or free? I ask this question because you have to understand this. I give you blah, 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 everything. Okay, now I ask you, unbalanced force or free? Unbalance is a force because it's the source of the vibration origin is force. Misalignment force. But unbalance also can be combination as a free, like a bridge failure, bridge collapse because force and free is superimposed. Bearing, we have both force and free. Electric carbon, also force and free. Here the answer. because it's forced by electrical current. It's not about vibration. It's not related to vibration. So this problem mostly happen to two-pole motor, very sensitive for electrical problems. So this is the answer. Force, but sometimes also free combination. Misalignment, force. Bearing, force and free. Depend on failure phase. When we learn about bearing, we will learn about phase of bearing. Okay, before it's fail. It starts from phase 1, phase 2, phase 3, phase 4. But not today. I talk about bearing. What is the purpose of bearing? Here's bearing, right? What is the purpose of bearing? Two types of bearing. The left-hand side we call hydrodynamic bearing. Somebody calls slip bearing. It's work based on hydrodynamic. The right-hand side is low elements. Its work different. It is hydroelastic. And if I tell you, you won't believe me. They don't need grease. They don't need oil. But they have to use grease. They have to use oil. Because without grease and oil, it's fast failure. But have grease and oil, also failure. But it works different. This work under hydrodynamic. This will work under hydroelastic. Grease or a film of oil became harder than steel. I said harder than steel. That's why they don't need grease. They don't need oil. They need only very tiny film of oil, not real liquid oil. And grease is a terrible for bearing, but it necessary for the cheap machine. So go to machine in your plant, in your factory. Cheap, low price machine is made from low bearings. Expensive machine made from hydrodynamic bearing. If we talk about the motor, IEC code said any motor larger than 1 megawatt must be hydrodynamic bearing. That's the point. Because the big motor is difficult to repair. So they have to use hydrodynamic. For 30 years, never taught this. But we open and inspect every year. Bullshit. They decide for 10 years, not every year. Lifetime is 30 years. Okay, but my practice, when I work in shell company, we limit at 10 years. Because after 10 years, we never know about the delamination. Delamination. Yes, we don't know this. So we just throw away 10 years. During 10 years, we never touch. But 99%, we open this bearing and inspect every year. So the machine fails because of your hand. That's why we call premature maintenance. Machine still healthy. We open it, we inspect, but it's not come back at its original. That's true. Okay, next. So bearing is device to fix five degree of freedom, allow 1 degree freedom. That means moment about set axis. We don't allow bearing to be translation, moment, translation, moment. So we have two bearing to stop moment. So that's a way of bearing. We detect vibration because we want to know what happened of 5 degree freedom. We detect scalar at the bearing to know what happened to the moment about Z axis. That is a theory. Okay. That's why we measure to know vector. We want to see the bearing sound. Bearing sound. That's related to the moment about Z axis. But the real world is not rigid body. Now you can see motor. I switching between two drawing. That's happened there. Okay. Is vibrate. And the point is, it has only not only this axis. Because even this, we have 3 axes already. Okay, but it make you better understand. So that stands for 1 degree of freedom. So if you understand 1 degree of freedom, that means you understand 3 degree of freedom. But real one, we talk about 5 degree of freedom. 5 degree of freedom. Okay. Oh, sorry. So I pull down here. A circle here, bearing. Here is a bearing. Footing. Here is footing. That is the way. Again, no young people. Old age, middle age, experience. New people cannot interpret vibration because you have to know machine design, understand machine. Jason just mentioned in the morning, right? Don't look at the wall chart. What spectrum look like? And then point out, that's a problem. It's not like that. Okay. Now, here. 4 bearing. 2 bearing is motor. 2 motor bumps. That's why we have to measure X, Y, X, Y, X, Y, and Z. And Z. In this case, it's 2 Z. That means we have to measure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have to measure 10 point. 10 point to understand 5 degree of freedom. Let me repeat again. We have to. Hello.
Yes, yes, sir.
Okay, we have to measure 10 measurements for this pump and motor string to understand 5 degree freedom of pump and motor. Somebody use 3-axis sensor. Hello? Somebody use 3-axis sensor. Don't trust this. Because sometimes it's not checking like you expect. I have machine. Somebody tell you, oh, my sensor is good. I can put here. I can measure 3 degrees of freedom. Only one here. ISO standard 13373 not allowed. NASA not allowed. You have to measure here, here, here. Because who know? Machine may vibrate at this form. Maybe vibrate at this form. Then you measure this. You lost. You lost. Only 5 minutes longer. Why so lazy to measure? See my pen? I can vibrate like this. I mean the machine can vibrate like this. Again, it can vibrate like this. We can vibrate like this. We can vibrate like this. And you just rely on one point. Put sensor here with 3 axes. You lost. Just measure 1, 2, 3, 4, 5. What's the hell? Just 2 minutes, 3 minutes. Not so crazy. 1, 2, enough. No. Be careful. Sales people will lie to you this. They can tell you, I can put an elephant in the didn't hole. So this is an ISO standard. We have to measure X, you see X, Y, and Z. See X, Y, Z. It's standard. In the vertical machine, you have to put like this. This is standard. Even the number, we have to put like this. Number 1, number 2, 3, 4, 5, 6, like this, according to the process for direction. This is standard. Okay, that's the way to measure. Not relies on just mouse sensor here, stand for 3 axis. You're wrong. That's the way of measurement. This is IEC motor, how to measure. Okay. Now we talk about the basic vibration. Now we come to this, okay. Let me go to this slide, but this slide cannot link. There you go. Okay. Okay. You know bekerja? 30 years ago, 40 years ago, this is the most advanced sound and vibration of the world. Today, no. Because people also know the same as they know. You know Cheng from Germany, also famous. I work with Cheng since I was young. Yeah, but today is no more. Okay, but okay. Fundamental is fundamental. Basic of vibration. You have to evaluate machine condition. Why we evaluate? Why we evaluate? Because we want to manage the list. Hello? Can you hear me?
Yes, yes, we
Okay.
can hear.
Okay, we have to evaluate the machine because we want to manage the list. Why we can manage the list? We have to recognition ongoing machine damage or symptom. We have to identify the cause and damage. Then we can prognosis. That means we manage the list when it's going to fail. So be careful when you measure vibration and then tell the boss, hey, we have to do this, do this because of this. No. Okay. Okay, we don't like this. Okay, this hard to explain. We don't want to like this. Too late. The cause of this repair is not just bearing. Sure, we have the secondary damage. Yeah, and cost higher than bearing itself. Diagnosis method, vibration analysis. Okay, vibration is good for dynamic, but sometimes you have to use another. From your case, maybe you don't need to see expansion, except the steam turbine. Okay, sometimes we have to measure expansion of the turbine casing. We have to measure temperature, phase, lubrication analysis. That's your job, right? HYPROWIRA. Yeah, your eyes. Sometimes you have to use the ultrasonic sound X-ray. But this one, we have to stop the machine. Vibration, you can, we have to do why it's running. So it's good too, not to object operation. We are doctor, right? Feeling. By two, today is by electronic. Okay. That's the way measure in overall, this we call overall vibration. They don't know about the detail. They know just the whole amount of energy. This we call overall vibration. Today is still used in ISO standard. ISO stay on overall method. Make you easy, but it's not go to deep detail analysis. I tell you, today NASA also not accept ISO standard. I will show you the last section. That's the way, that's the method. Spectrum. This one is free vibration. So we go bump test. Sometimes we have to discriminate a signal in front of us. Is it false or free? Sometimes they have to prove free vibration to see here which one is false or free. Okay. That's the way to measure vibration since 1926. Okay. Today machine. Okay. not today. In the past machine. Okay, today is not. So we measure vibration, which is displacement. But in practically, we measure acceleration and then indicate velocity. So the unit of displacement, micrometer, millimeter, something like this. Velocity, millimeter per second, inch per second. Acceleration, meter per second square, or G. Somebody still use G today. Okay. So we talk about signal. We have narrow band and broadband. ISO standard based on energy cover 10 hertz to 1000 hertz. Again, don't use everything at this length. This one just for 108.163 only. Okay. Narrow band, today we go to spectrum. But before it's not, because no spectrum. That's in that time we have to use tracking filter. Today we don't use anymore. But this technique we use for balancing. Balancing today. Okay. That's the way of unit. I mentioned about the 220 volt your AC line. We talk about the 317 zero to peak from your electric in our house. Yeah, that's where. So when you stay IMS or peak, depends on you, but not peak to peak. That's for displacement. But I recommend you stay with the IMS, unless for special case. So this signal. Signal A, signal B is combination. So we call modulation. Signal vibration is a complex signal from multi signal combination. Okay. Like a sine wave, like a square wave, is combination of the sine wave 1, 3, 5, 7, 9, like this. Pure sine wave, it becomes your pure spectrum. Sinusoid wave became like this. Okay. Again, spectrum based on this, assuming to be sine. Okay. This is old fashioned, okay? No more today. This is still used in the sound analyzer, but vibration no more, because today our digital is much faster. Okay, but see it. Displacement, low velocity, low frequency is very good. When it runs faster, it's no good. If you go to velocity, it's flat. If you go to acceleration, low velocity, low frequency, no good. High frequency good. That's why we indicate this to this. Okay, next. So mostly vibration, it start machine, minimum is 600 RPM. So we mentioned to measure 10 Hertz to 1000 Hertz. This is ISO standard, ISO 10816. That's 3. Okay. Sometimes we understand that we measure another frequency band. Now you understand this already, right? Match, spin, damping, stiffness. It's the same, you see. Okay, we talk about the absolute vibration, velocity, acceleration. This absolute. Displacement. We talk about relative vibration. That's why I say a different way. Now we stay with absolute vibration. Okay. If you work with the turbine, that's why we talk about relative vibration. Orbit, I mentioned before, is a relative vibration. Again, the way to measure. Okay. That is kind of sensor. You cannot see the sensor and tell this is acceleration or velocity. You cannot. Look all the same. We have to look precisely. Then you understand from here. Because by the number, sensitivity will tell you acceleration or velocity. But today we stay on acceleration. Much better than velocity. But if you use velocity, you don't need to calculation. I mean inside machine calculation. Okay. We don't do it, machine do it. That stay in the expression. Okay, okay. That's a relative. Yeah, this absolute. That's a sensor of relative. It's work different. Okay, it's work in the eddy current. I won't come to this. Don't come to this. Okay, just pass this. This is sensor. Okay. Sensor is mounted on this, and to see what is shaft is moving. That's why they need two axes. That is a way of vibration. When you measure day by day, and when it fails, it's go to exponential. So sometimes too late for you. Okay. So something happened to this, you have to ensure and then plan to repair. Yes. I tell you this is wrong. Not outdated. Sorry. Today we have up to number 6. So ISO is separated into parts. This absolute, this relative. You see? Okay. For machine, today we don't use number 6 anymore. Now we came to number 8. Okay. When you measure engine, you have to use this number. So don't mix up. I saw many people use this one, stand for everything. It's wrong. And the most important, this is not spectrum. This is not narrowband. It is overall vibration. So don't try to interpret spectrum based on this, because it's not sine wave, it's the real world. That's where to measure. Okay, we don't need to understand this. I mean, we will explain you later. Okay, that's a bearing. Okay, we just pass this first. Sorry, กล้องผมไม่ติดแบบนี้ก็ได้อะไร Stop Stop sharing. Look for the phone. Either. I'll put it to TV. Either. Yeah. Good. Butเดี๋ยวไทยเดี๋ยวเก็บเรื่องแม่งไว้ผมไม่เอานะฮะ phone not available ก็ make sure แล้วต่ออย่างแค่นั้นเองไอ้นี่ไม่เกี่ยวนี่ต้องเปิดคอมพิวเตอร์ผมไม่แต่เขาได้ยินเสียงไหมไม่ต้องเอานี่ Can you hear me?
Yeah.
Yes, we can hear you.
Okay, we don't use telephone. We don't use video. Now you understand this, okay? Number. Now we go to signal processing. Back to the basic, forward to the future. Okay. Estimate new measurement point record means to show analytic brilliant answer to every problem. Okay, that's the simple of the simple harmonic. Okay, that's why it's the way of vibration, because they have displacement over time at the speed, angle, or position. That is the way of vibration. Now you know this. Okay, we go back. Basic, static, slowly, like temperature. Dynamic is fast, like a vibration. Dynamic, signal. Fundamental is amplitude, frequency, time, shape. Amplitude, you know already, a proportion of severity of vibration motion. Expressed in peak to peak, third peak, RMS. I mentioned to you, Ceylon RMS. Okay. Frequency. Some people use order. That means X1, X2, X3, X3, or 1X, 2X. That is. But be careful. Vibration is not only X. Expert people must able to analyze no X. X is simple. Okay. Signal share, waveform, simple, complex. We have to recognition pattern. But Jason mentioned, even you look the wall chart for the pattern and then conclude the problem. Not. You have to know the machine. Timing is a phase. I mentioned to you, just a phase. Just a reference something. Okay. A signal like this. You see, IMS different. That's why we have to stay at the one IMS or 0 to P. Don't mix up. Okay. Now you understand already about displacement, velocity, acceleration. Okay. That's the way of signal processing. You have sensor, go to signal condition, go to the converter analog to digital, and then go to processing. That's the way of that is a proximity probe or relative vibration. Okay, we don't talk about. So this is a velocity sensor. I mentioned to you, it's no good today. Okay, because have limited range, but also is minimize signal processing because it's direct measurement velocity, but it's limit length. If you go to the analysis, don't use velocity. That expression. When you look outside, it's the same. So be careful. Okay. Frequency up to 10,000, 15,000 hertz. Okay. This one, no, only 1,000. Sensor can be output to 4 to 20 milliamp or to wanted, depends on your requirement. Okay, now we talk about the signal. Vibration is AC. DC is just static signal. Different. That's the inside the processing, the sensor. I just to show you about this. When you put long cable, you also lost information. Long cable became capacitance. Then you lose the high frequency signal. Okay. This we call about sinusoidal. It's not pure sine wave. Absolute sine wave when you convert to FFT. That's the cable loss. Okay, this inside your in system. Okay, this our job to make it. Okay. In the morning, we mentioned about the JSON sampling 1,028 samples per second. You see, if you're sampling too slow, from signal like this, it became only this. So you lost information. That's why sampling has to be very high sampling. By standard, we have to oversampling 2.65 times above maximum frequency. So today, if your machine still has sampling about 1,040, something like this, its limit only 1 kilohertz. So don't let people lie to you. I just had this one. Okay, this is the way of when you convert time waveform to spectrum. We have leak. I tell you, this is assuming. It's assuming everything. Even leak. We are allowed to leak frequency. We are allowed to leak frequency or allowed to leak magnitude. But mainly, we just stay on handing. Oh, สัญญาณแย่ไป So mainly we stay on handing. Handing is give you accurate frequency. ใช่ปิดที่ไหนเปิดใหม่เหรอเดี๋ยวบอกเครื่องผมมันกดปุ่มผิดตลอดอย่างนี้ Just a minute. Maybe Iวิดีโอนะนี่ยังไงล่ะก็ปิดไปแล้วนี่เนี่ยปิดเนี่ยนี่นะโอเคเป็นยังไงนะOkay, carry on. Maybe because I opened another application. Coming. Oh, here. That is the meaning of window. So we use on handing. We have a very good frequency. We have hamming. We have better frequency, but we lost the signal here. We are backman. We lost frequency, but we accurate magnitude. That's the way of when you set in the machine. Okay, but in V-Mer, we stay constant with handing to avoid setup. That's when they leak in signal. Okay, that's the way to leak. This window when you convert to spectrum. Again, line. Today is no more. Okay. ของเราไอ้500เท่าไหร่3,200 ลายถูกไหม So today the lowest line is 3,200 line. But I wonder some people still use 400, 800. In the morning I mentioned 1,600 line. No. It's not. It's my mistake. Minimum is 3200. HCD 55 work on 5200. V-Mer 100,000 line. Okay, that's V-Mer. Give you accurate. Only 2-3 machines in the world that lead 100,000 line. Okay, that's the way. I mentioned about integrate and cannot integrate when you integrate non-linear signal. Because of this, because you don't have a time at the constant. We don't have constant time. That's why it cannot integrate. เป็นเหมือนกันตัวเลขเนี่ยเสียงมันก็เสียงหายอ่ะฮะ Okay, I try to เนี่ยชัดเลยเนี่ยพอปิดเนี่ยชัดเลยโอเคตอนนี้ก็เรามาดู oh sorry สิ่งไป From this one, I try to say that's the reason why we cannot measure vibration in piston machine. Engine cannot. You cannot see spectrum because it cannot convert. It's not by indication from time 1 to time 2 because it's not constant. Okay. Okay, that's where sometimes it's coming like this. So many vibration. Some vibration tool tell you, hey, I cannot convert signal by ตัวนี้ผมไปโดนแล้ว Hello? Hello?
Yes, yes, sir.
Okay. Sometimes you cannot convert to spectrum. It became like this. So random signal, it became like this. Random signal. So again, spectrum is just to convert under assuming. So don't rely on spectrum every time. Okay. It's late. Okay. Okay, now we stop. Let's go to another. Now we understand signal processing. Now we go to vibration for beginner. Now going fast because we almost finished. Okay. Somebody know contest? Contest today belong to GE. To GE, okay. It's good machine. But we can do GE. I love it because the price go up. It just repeat to me, okay, why monitoring something like this. That's why we can learn faster. Why monitor? We know already, right? Because we have to understand everything, vibration, to see it, understand everything. That's why we monitor it. We monitor to manage, okay? To manage, to learn, to understand and manage. You understand already, okay? Because A to B is shaking. The source of vibration palm vibration, motor vibration. It is lateral vibration. So up to now, no question anymore about torsional vibration or lateral. We talk about lateral vibration. Again, normal tool cannot measure torsional vibration. And many cases, it's happened to you, but you don't know. Sharp brake, coupling is failed, mechanism failed, sharp key is failed, mostly come from torsional vibration. And it's come from you because you don't know. And you modify, add the mass, put VSD to the system, and when you change the frequency, is maybe go to that frequency that manufacturer want to avoid. Again, the cause of vibration. This is not the cause. Be careful. This is a result. Okay. The cause of the vibration is we call excitation, unbalance, misalignment, and fit induced only. So this paper, this part is wrong. It's not the cause. Okay. But okay, the force is repeat force. Exciting is repeat. Okay. So it is a cause. Unbalanced bend shaft, unbalanced mass. Okay. Misalignment. Okay. So we can interpret looseness. When looseness element inside is moving as a nonlinear, so then cannot convert to spectrum. Then you see the spectrum, or the x1, x2, x3, blah, 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 because it cannot convert to spectrum properly. So that gives you the looseness. Okay. Resonance is a free vibration. That breath has a resonance at 0.2 Hertz. Wind blow, excite vibration to breathe.
Sorry, Kun Manorom. We cannot see the slide.
Oh, sorry. Yeah. Okay. So see the beginning, right?
Yeah.
Okay. So that is a contest. So contest is from New Zealand, but today it belongs to GE. Then I love it because price goes. Okay. Now we explain since I talk since the morning. Why? So no need to go repeat. Okay, just go to quickly. We know it because we want to monitor it. To monitor it, too many exist. You know the vibration, right? Shaking at the constant period. Yeah, that's vibration. Okay, the source of vibration is give you from pump plumber, motor plumber, bell, fan. From here, everything is lateral vibration, not torsional. So today, up to now, don't need to ask me again, what is lateral, what is torsional? Okay, if still not, just leave the message to HYPROWIRA. I give the answer. The cause of vibration. Be careful, this is not the cause vibration. Looseness doesn't cause vibration. It's a consequence. So be careful. Resonance is the cause. The cause of vibration just only unbalance, misalignment, fluid induced. All it is. The rest all consequence. Of course, unbalanced misalignment is repeat force. A bridge collapse because there is a force from wind. Because windex, sometimes we call wind induced vibration, cause the vortex and then push the bridge. Then synchronize with the bridge its own vibration, what we call free vibration or resonance in the same frequency. Then it magnifies until the bridge is break, non-stop it. Before to this, I almost forgot to show this. Look at the board. After this section, go to any factory with the 5 column, like a when fast step. You can see they make like this. Just wrap around, okay? This one to destroy vortex. If the wind blow, is no vortex behind. So this is a reason, okay? This is a reason. Without this, it will vibrate, okay? That's why they have to put this lip. So the wind blow, it change the way. It's change the way. So no way to become vortex. If you look top side down, this is a stack. The wind's coming, then became turbulent. Then frequency is different. That's why it's very bad. Okay. So that's the reason of the bridge collapse, because you have repeat force from the windex, then coincident with its own free vibration, then magnify the vibration. Okay. So it's the source of vibration. Unbalanced misalignment. Oh, this is unbalanced. Sorry. Okay, misalignment. Okay, keep the problem. Looseness. We can see the spectrum. That spectrum cannot convert properly. It tell you x1, x2, x3, x4 because movement of looseness is non-linear. The same as a piston machine. Resonance. That's bridge collapse because of resonance. So resonant and free vibration is the same. You see, child is free swinging. Okay, why we monitor? Because we are doctor. Okay, to manage our health, we manage our life. Okay, that's the way. That's why I want to go over this. I don't talk about the power consumption. It gives you save the money. If you high vibration, you waste the money. In the term of power. You know why? Motor. What is telling you motor speed is 1,500 RPM. What is telling you is yes, 1,500 RPM. What is telling you 300 RPM? Line frequency. Motor don't know how much they run. They try to synchronize the line. No matter what load is, they want to try to synchronize the line. So when we have the vibration, but motor is want to rotate, not shaking. So they don't know about shaking. They try to learn to synchronize the line frequency. So you lose power, efficiency. That's why you pay a lot for the money, for the power. Okay, that's it. I don't go to detail about this. People come to here, that means they, because I think you know vibration already. Okay, that is the, how is machine vibration described. Oh, ไม่ขึ้นอีกแล้ว Just a moment.ไม่ขึ้นเลย ตัวนี้คืออะไรนี่คิวโดอะไรมาเนี่ย Okay. How this machine vibration? You can see why? Hello?
Yes, yes, we can see it.
Okay. No, the two most important methods in describe machine vibration. Understand amplitude, frequency, and spectrum. Since the morning, we just talk about this. Okay. We don't need to know anymore vibration. Okay. We know already waveform already. We know about time waveform already. You know about unit already. Frequency is enough. Waveform is okay. Okay. Convert waveform to spectrum. That's the way. You understand already. And again, don't rely on spectrum every time. Okay. Okay, this is the list, no problem. Today we go to just basic. A signal, sine wave, when you convert to spectrum, is very good single element. The complex signal is combination also is discrete. square wave is like this. Okay, now we finished signal processing. Now we talk about the ISO 10816. What is this? Any better than this? Let me quit here. เครื่องผมไม่ไหวตัวนี้ Why vibration is the role player in modern maintenance? Okay. It's the best parameter. Okay, but you have to understand it. Background ISO standard. Okay, before became this ISO standards, you know, it takes more than 30 years. From left top to the right, to the bottom left, to the right. That's the way of ISO 10816. Today is we go up to number 8. Okay, we improve from number 6 to number 8. But in your application, mostly you say with number 3. For relative vibration, we use another number. So don't try to use your vibration meter. To measure turbine is meaningless. So 10163 decide to detect industrial machine from 15 kilowatt at speed minimum is 120 RPM to 15,000 RPM. But when you measure 120, you have to set differently. But people never set. People all stay at 600, not 120. So that is the way. So we detect 10 hertz to 1,000 hertz. Okay, and give to this chart. Again, this is not standard. You cannot point out good or bad, but it gives you some reference, only reference. NASA won't accept this standard because it's too rough. But okay, help you without nothing. You cannot even use this standard in the factory because it's different. Now I show you. The left side is from standard. Oh, sorry, from factory. If you compare to standards, it gives you red color already. It tells you fail. Even it's brand new in factory. So be careful when you use this standard. Yeah. I don't want to come to this. Need to confuse. Okay. This standard is derived from energy. How many million revolution? That is fail. Hello? I don't want to talk about bearing. Let me go to next training. Okay. Next training we go to bearing already. Okay. We talk about this bearing design. Today, I just want you to understand basic of vibration. Okay. I just give you example. This is 0816-8. Very complicated. Okay. So don't use even spectrum. We don't talk about spectrum in ISO standard. This machine. Oh, ไม่ขึ้นอีกแล้วทำไมเฉยวะต้องช่วยดูหน่อยที่ผมก็เพื่อนอยู่ถึงไหนเมื่อไหร่ก็ลงมาแล้วเมื่อกี้ขึ้นใช่ไหม We talk about 1016-8. This is for piston machine. Okay, receive compressor. Because it's non-linear. It's not about not linear, but it's because ISO 1016, you cannot use spectrum. Again, I want to emphasize when you analyze vibration, don't use spectrum to compare with ISO standard. Totally different. ISO, we talk about energy in the overall frequency. Spectrum is discrete frequency, different. Okay. That's the way. It's a machine. That's why we have to measure through axis. And not only this, okay, that's standard to measure. Then we have to measure like this, A over B over B over C. Okay, like this. When you do measure foundation, value must be this. They don't talk about the value alone. They talk about value ratio. You see, it will complicate. This that's number 8. Just B over B, B over C, C over D, like this ratio. Because this machine, by its nature, is vibrate already. That's why they have to put ratio. Okay. Let me stop. I just let you know the overview of vibration. Number 3, everybody know, everybody living it, but don't understand precisely. First of all, it's based on velocity and in RMS. And here, they have 2 bands set. If you set 10 to 1000 for the machine running above 600 RPM. If you go to measure like a cooling tower fan, we have to set 2 to 1000 RPM. For machine that's run from 120 RPM. That is the meaning of this standard. Again, there's a pump. A machine smaller than 15 kilowatt cannot use standard. Okay, must be this. They classify rigid and flexible. Rigid and flexible. I ask you, what's the meaning of rigid and flexible? People assume rigid, that means is direct mount. Flexible might be mount on a spring or rubber mount. Is not always that. Okay. The definition of rigid or flexible is operating speed is under its own natural frequency or higher than natural frequency. That is the reason. Not about spring, rubber, rigid, concrete. No. So you have to know rigid, flexible to find out its resonance first. That is how to use this table. But okay, 80% spring and rubber mount is flexible. Okay, mostly. But it doesn't mean. Sometimes rigid also flexible. So be careful with this. That's the way. And for this one is motor. Motor is very good. So this table is very accurate for IEC motor. Okay. But it's not universal too. Okay. Be careful with this. But okay, 90% people, I say 99%, use this standard. But NASA is not accept. Okay. Don't be careful to use this. This standard cannot use to point out good or bad. Just help you some certain level. Okay. That's why we put this function in enhancement in V-Mer to make it accurate. Many cases, if you follow this standard, it will you fail. But when you open the part, it can run over years. Yeah, but you open already. Okay. Now, screw compressor. We also have another standard. So we have another standard. This one is ISO 10440-1. So if you want to use standard, you have to follow this standard. Okay, you have to follow this. For screw compressor. Okay, so you can use ISO 1016. You cannot. You have to use this. Okay. And you have to measure in 2 band. You see, 2 band, 10 to 1000, and then 10 to 2.2. That's the way to use standard. This one very close to NASA standard. Standard just split to 4-5 band measurement. In future, maybe I may develop V-Mer to meet NASA standard. Okay. So as your choice, ISO 1016, or NASA? Okay. Next. Now you see it's on standard. Any better? Yes. ISO 176 is just overall. We have dedicated number 3, number 4, number 5, number 6, 7, 8. So don't just mix up only 1016. Again, NASA won't accept this one. Let's go to NASA. NASA has standard. He called about the reliability center building equipment acceptance case. And that's another book they call collateral equipment. That's mean not about rocket, not rocket, only other equipment related to NASA factory, not rocket. Okay. Okay. Now we go to page number 53. If you want like this, just contact to HYPROWIRA. This is simple NASA. Even borrower, you have to set the band like this. Okay, so he has many things from motor, everything like this. We have bands, there's speed band, yeah, like this. Okay. Okay, that is, we have new standards, of course. We have even special ISO for screw compressor. We have ISO number 8 for piston engine. We have number 6 for small piston engine. We have number 7 for rotodynamic machine. You see different. And why you just mix up with 1, 3? It's not, okay? 3 is just general equipment in factory. Okay, I think we almost come to the end. Come to this way. Time domain is true, but okay, belong to your setup frequency, setup sample rate. You have to know this thing. Very sophisticated equipment. It gives you really complicated to use. Very simple machine, just for people who are not skilled. So then make easy for you. So we use a very expensive machine, you have to know precisely how to config inside. Okay, we talk about FFT. No need to say again, fast. Okay, FFT has a weakness in random shock, not linear. Up to now, I think you understand already how you verify FFT. Okay, random shock is go to random. Random. Periodic. This periodic, this random, this can convert to spectrum. Depend on this. This one cannot convert to spectrum. When you go to spectrum, it's coming like this. This is random. Okay. Periodic can do. Oh, I love it. Spectrum. Yeah, very easy. Okay. And then looseness. Random cannot convert to spectrum. But looseness is a random mixed up with periodic. So when convert to spectrum, like this. Okay? Because when you integrate at a certain time, also you get. Another certain time, you get. Another you get. Then it's coming like this. It's not properly. This one, you cannot integrate. So they put the signal, everything to the left hand. Okay, it is not low frequency. People always misunderstand this low frequency. This that people always misunderstand this low frequency. It's not. This means a frequency that cannot convert to spectrum. This one is based on non-linear motion, modulate with linear motion because it's looseness. Machine is looseness. It's shaking because they have periodic exciting and then looseness. So combination here, they cannot convert to spectrum. Then spectrum coming like this. Because this is a frequency domain. This is time domain. They cannot convert. Again, this is more accurate than ISO, but it's difficult. Okay, I will develop new version V-Mer to meet this NASA. Okay, and even ISO, they also start to migrate, not to stay on 10816. Okay. That's why we have new number. Okay, next. Now understand this. I explain you. Be careful F50. But also happy. Because most of your machine, 80%, F50 can cover it. It's okay. That is the way of when we convert to FFT. Here is a two signal modulation. When we convert to spectrum of FFT, it became to this. Center frequency and sideband. I talk about sideband when you learn with me about deep vibration analysis. This became the heart to analysis non-X. For me, X is peanut. X is easy. I will teach you how to analyze non-X. People are afraid to see non-X. That's why they use zero light spectrum. Yeah, to close their eye. Very danger. Okay, come to this one. Also come to with a more complex signal. But it's still deterministic. Then you can convert to spectrum. See? Here, the right top, you can convert to spectrum. And show like this. Look, up there is high frequency. Sorry, no. It's the same frequency, but different amplitude. Sorry, the sound is not good. It's the same frequency, but different amplitude. So when you convert to spectrum, it's coming like this. Come to the left hand. High frequency is more population, right? Then it convert to here. From here, high amplitude, and then low amplitude, low, and then high again. So the population is not like a left hand side. So convert to spectrum is like this. Okay, come to the bottom. That is the idea of sine wave. But again, you never find in real one. But you have, in case of the unbalance, you will get this. Okay. Okay, that's the way. Come to the bottom right. That's the way how to change, convert the time domain or time waveform to frequency domain. You can see it, you cannot. Then if you get more periodic. Hello? Hello?
Yes, sir.
Hello?
Hello.
Can you hear me?
Yes, we can hear you.
Yeah.
Yes.
Okay. For more periodic, that means more spectrum information. Now the bottom one, chalk. You cannot convert spectrum. You see, that means be careful when you measure, when you analyze vibration. You have to know. Don't believe a display showing in front of you. You have to understand. So don't overlook time waveform. But luckily, 80% of your machine, your spectrum can convert, but not all. People always misunderstand me. They think I'm anti-spectrum. Not. I know spectrum is. People who blame me, they don't know spectrum is. Okay. Any new technique? Before we go new technique, we go to old technique and still helpful today. Of course, spectrum, very effective for linear signal and periodic. Again, envelope, even very old technique, but very effective for bearings and gear analysis. Even today, statistics give good information. Today, many cases we don't need to know even looks like, don't need to know even spectrum looks like. You can see the number from calculation and tell you the problem. For example, you go to kurtosis or crest. That's why it says many cases that it's not necessary to see waveform or spectrum. A new technique, we have multi-band pass frequency to help you complex signal. We have wavelet to measure shock and linear. And again, NASA use multi-band, more accurate and reliable. And we have new technique, also septum. But septum is very rarely used in vibration because it's not compact. But today, spectrum is used for voice analysis. That is the way of, I think we call everything. Let me demo the real one to you. What's happened? Can you break for drink or something for 5 minutes? I will set up V-Mer to this one. Give me 5 minutes or 10 minutes. Okay?
Yeah.
Okay.
Manorom,
10 minutes. Yes, sir.
there is one question from participant.
Uh-huh.
They ask about why the vibration occur on generator, but there is no, the temperature not high, not hot.
What? Say again, sorry.
There is a vibrate in generator, vibration in generator, but the temperature is still normal. Can you explain why?
I don't know when you asked them with the vibration, that's why I'm confused.
Okay. Yeah, you can continue. I will check.
Oh yeah, check this and then send by message or something that answer you. Okay, give me 10 minutes to set up the beamer.
Okay. We will wait. Bapak Ibu mohon kita tunggu sebentar. Pak Manorom mau set up satu teknologi yang mungkin bisa menginspirasi kita semua. Terima kasih.
Sama-sama.
We have 10 minutes left.
Okay. Okay, now you see my video. You see it? No, no. Huh? You see here display? Hello?
Yes, yes, we see the display.
Now display is coming from this machine. From this machine. Oh, sorry,นี่ไม่ขึ้นไม่เป็นด้วยอ่ะงงแล้วเดี๋ยวเตือนบทแน่ๆOh, I cannot demo your เขา10 นาทีเอง Okay, I turn on V-Mer in the morning, but it's just gone coincidentally. Huh? ไม่ใช่ Okay.
Bad mood.
Battery is gone for the V-Mer. I turn on since the morning. My mistake, sorry. So I cannot demonstrate our V-Mer, but I want to answer the question. Okay? Hello?
Yes.
Now you see me, right?
Yeah.
No? ตัวนี้ผมไม่รู้จะเห็นไม่เห็นเนี่ยจะรู้ได้ไหมเนี่ยเห็นไม่เห็นเนี่ย Can you see my display?
Yeah, yeah.
I'm very sorry, it's coincidence. I turn on V-Mer in the morning and just battery is finished. Because battery designed for 7 hours continuous. Okay, new technique. We have automatic vibration. Okay, I'm sorry I cannot display you. Coins just now, battery is gone. This V-Mer, new V-Mer, we have multi-band analysis. We have wavelet. Again, this for experienced people only. For non-experienced, forget about this. You just rely on automatic ISO, automatic bearings of the unbalanced measurement is enough. This is more powerful than people already. But if you are a real expert, I give you a special device to be multi-band wavelet and sound analyzer. V-Mer will come with microphone. You just connect microphone to V-Mer, became sound analyzer, okay? And you can connect sensor, became vibration, 2 in 1. So only sound analyzer price is the market is another $8,000. But I give you free. Okay, that's a V-Mer. On the question, a new technique, yes, automatic analysis. I'm not the first one to develop automatic analysis. CSI 031416 is automatic already, but it's complicated. It's hard to understand. Then followed by Falcon as automatic. And also I make number 3 is automatic. And I believe Bearing analysis, I am really advanced. Bearing, I believe I am the most advanced from anyone. I don't talk about unbalance or misalignment. That is peanut, very easy. Bearing is more accurate, more important. Okay, online. Somebody mentioned online. Online vibration, IoT. It doesn't help if no automatic analysis. You put online, but you don't know what's the meaning. It's useless. So online with automatic analysis, that's very good. I will give you online system to hook to any brand. You have any brand online, I can put automatic for you. Okay, let's talk with your HYPROWIRA. Again, I cannot introduce you the V-Mer. Okay, I'm very sorry. Okay, come to the question. Let me explain why vibration related to temperature. That's your question, right, Hendra?
Yeah.
I think he tried to ask the question, why machine is fail, but temperature is not high, right?
Yeah. Yes, that's right.
The point is, temperature will high in some certain level, and then it's go down before it's break. This is the problem. So when you measure temperature, be careful. A short moment, 1 week before it fell, it's cool down. Now answer your question. By nature, it's cool down first. In bearing, before it fell, it's cool down first, then it fell. It's hotter, then it fell, it's cool down before it fell. Because why? Higher clearance. 5 degrees freedom is gone. That's why it's cool down. Okay, answer your question. Another question?
Yes, there is any one question from Pa Eral. How we prevent resonance occur?
Please repeat again.
How to prevent resonance occur?
Resonance of what?
Yeah, happen. How to prevent the resonance occur?
Occur, right?
Occur, yes.
You cannot prevent resonance. You have to avoid it because it's nature. You have to live with resonance. You have to live with resonance. You have to understand resonance. We cannot eliminate resonance, but avoid them. Suppose this resonance resonance. By machine design rule, we have to avoid by design rule. We have to avoid plus minus 20% from resonance. That's by the rule. What the rule says, you can go to plus minus 10%, but you have to precisely study. Resonance, again, you cannot eliminate it. It's by nature. But we have to avoid less than. Answer your question?
How is spiral? Answer the question, Pak. Yes, they said, yeah, we can avoid the resonance.
Yes,
But
Pak
many-
Jun. Thank you.
You are welcome.
But many cases people don't know, especially when you use VSD, variable speed drive, and you move to resonance with the problem. And resonance, when you're feeling, you're touching, is a lateral vibration. Lateral vibration. We also have torsional resonance. That is really dangerous. Torsional vibration itself is hardly to measure. So we have resonance. It's terrible. Every machine, when it comes to factory, before go to the market, they test, they tune everything already. But for us, we don't know. People don't know. Use a VSD to change the speed. Then go to that resonance. Again, if lateral vibration, lateral resonance, you can feel, you can measure. Oh, it's shaker higher. But for resonance in torsional, you also never know. That's why sharp is break, key is well. So be careful when you change your speed. When you go to USD, people who say USD don't know. This is the important, okay? Okay, next question.
Kun Manorom,
Yes, sir.
I am Hambali.
Sorry?
I am Hambali. Do you remember me? Hambali is Shafan. I have one question from my user. Can V-Mer be entered by input bearing spec, gear spec, so that it can directly be reported to the bearing or gear? Which is the problem?
You want to put the
Ali,
bearing.
please show your face so Manorom can remember you.
You want to put bearing number in the V-Mer, right?
Yes.
To know the bearing fail, right?
Yes.
Why you have to know?
User want to know what number bearing this get a problem.
I saw you. Yeah. I saw you. I'll say again. Sorry. Emily, say again.
Yes.
Say again. Say again. Repeat.
See again.
Please repeat again.
Oh, repeat again. Repeat again my question.
Ya, ulang lagi Li. Tanyanya apa Li?
Can V-Mer be entered by input bearing spec, so that it can directly be reported to the bearing, which the which is problem? Can V-Mer input spec bearing, bearing spec, so that customer directly be reported or get reported from the V-Mer, which is the problem, bearing, which is the problem, what bearing front or other.
V-Mer itself tell you bearing problem from other. That's why I confuse your question. But I understand that is the old way to put the bearing number in it. But today is not necessary because V-Mer developed higher than has to know bearing number. But can do is really simple. I just put bearing library inside, just key the number, then it give you indicator, that's bearing. But it doesn't help V-Mer.
So
But
we
in
have 3
all
minutes left.
way, in all way, that's people need. I need bearing number to see bearing number, but today is no need. If you go to Falcon, you know Falcon vibration?
Falcon?
Yes. Falcon vibration.
Falcon vibration.
Falcon.
Falcon, ya, saya pernah dengar.
Yes. It's one plot, right?
Over here.
Right? One plot, Falcon. They don't need bearing number. The price higher than V-Mer 10 times. The analysis is bearing without bearing number. That's why I tell you we can do bearing number. I can put on it. But today, digital and software can analyze more complicated than to know bearing number. But if you want, I can put on it. But we have to extra charge for the bearing number because I have to buy bearing library and put inside. This is a problem. But not much. Okay.
But not much.
You
You can input bearing number to V-Mer system.
Yes.
Right?
Yes.
Okay. Okay, Kun, thank you.
Thank you, sir.
So the V-Mer can put bearing.
Okay. But I have to put bearing library inside.
Okay.
Yeah. Yeah.
Okay,
Maybe next
thank you.
session we will talk about V-Mer.
Rika Tusentori, Kun Manorom.
Yeah.
Rika.
Okay, I think we have 1 minute left.
Mm-hmm.
If any other concerns, sir, to present to us.
Okay. We have a training like this regularly. We go to pure vibration. Okay. Not. I don't touch any little V-Mer. So next time we training V-Mer and we training vibration alternately. Okay. So you set up the training. I have 4 training regularly in Thailand. Maybe I wish you to do the same. Let me open the screen again. That's V-Mer. Okay. I'm sorry. Just a minute. Hả? Mày thành bao là? Let me have this. Tôiไม่ขึ้นนะtôiเอาไว้เครื่องอะไรวะเนี่ยผมปิดไอ้วีมอะไรไปแล้ว โอเคไม่ขึ้นเอากูก็งงอยู่วะ Okay, we have from V-Mer, we have a new product. Laser alignment is a low price, and we can integrate spectrum analyzer in vibration in laser alignment. But it's not V-Mer. We call V-Starter. It's like this. Okay, it's low price. But okay, it's not powerful like a V-Mer. That's why we call V-Starter. So somebody who want to use a laser alignment with the vibration analyzer spectrum, and it's not required to use V-Mer. You can use V-Starter. It's low price. Okay. HYPROWIRA we have this. In Thailand, we have a good selling for this. This laser alignment with vibration, 2 in 1. Okay. That is vibration. You see this is a display of vibration. It looks like V-Mer, but I give you only ISO automatic, unbalanced, and misalignment. Automatic, okay? No bearings. Okay, let's come to question and answer. I have a regular training like this in Thailand. I'm sorry. Huh? Give me 5 minutes. Now we can switch on V-Mer. Give me 5 minutes, okay?
Okay, please.
Hả? Nó xuống đây. See. Mấy bài đó. Được rồi đấy. Okay. I think we have internet problems. Okay. We have regular training in Thailand about vibration. Today, we have training alignment with delegate. I training you alignment with delegate. When you understand, no need to buy less alignment. We have a training how to design maintenance. I have a training about balance, energy balance. We have 4 free training here, regular in Thailand. I can share to you by soon. Okay. Another training. Today I'll be training about vibration. And just overview. Okay. If you go to real vibration, you have to go to 6-day training. They're not free. That we charge the money. But for free, we have like this every month in Thailand, like this. But this one today we design special for you. Okay. And then we have another training, alignment with delegate. When you training with me, no need to buy less alignment. Why is it you? Because I want you to understand alignment. And then we have about how to design maintenance. We have training about energy balance. Okay, I will send you to HYPROWIRA to make announcement. That's all I give to you today. I think it's one day maybe it's too hard for you for new thing. So any question, just leave the message to HYPROWIRA. Then I answer you. Thank you so much, sir. Oh, Dunadi. Hello?
Yes.
Yes.
Okay, now your turn because I finished.
Okay, thank you, Manorom, for sharing us. It's very useful for us. We appreciate it very much. Dan kepada bapak-bapak, ibu semua, kami juga mengucapkan terima kasih. Untuk materi training nanti akan kami kirimkan by ke email masing-masing. Tadi kami sempat share beberapa nomor. Mungkin kalau ada yang belum submit alamat emailnya bisa di-share ke nomor tersebut agar kami bisa segera kirim materi presentasinya.
Rencana kita juga akan bikin grup.
Dan mungkin kita akan buka ini juga buat grup untuk vibrasi, jadi kita bisa saling share isu-isu ataupun teknologi terbaru ataupun kita bisa diskusi terkait vibrasi ini. Thank you very much for.
Let me emphasize this is such general vibration, okay, to give you overview because I don't know who will participate. If we go to detail, new people confused. We have a training for V-Mer especially for this, but this one is no V-Mer. And we have some problems about internet, blah, blah, blah. I will improve. This is my first time to full day training to you, okay? And even the article I designed is make you understand or not. Please comment, then I can improve it better and better. Thank you so much for everyone, sir. Terima kasih.
Thank you, sir. Thank you.
Yeah, with our pleasure.
Yeah, love you, everyone.
Ya,
See you next
Terima
time.
kasih.
terima
We have
kasih
like this.
Bapak-bapak
Yeah,
semua.
terima kasih.
Keep
Yes,
safe.
bye.
Terima kasih.
Bye-bye.
Terima kasih, Manorom.
I
Terima
love
kasih
everyone.
semuanya.
Okay.
Thank you, Kuntori, Kun Manorom.
Yes, yes, yes. Thank you,
Thank you,
sir.
Bang Bali.
Ya, thank you semua.
Thank you.